Thank you guys for coming. Thank you guys for having me. I hope you're having a good morning so far. I was just tweeting with the NodeConf hashtag that coffee really makes me anxious. I don't know if it's the same with you guys, but I'm like, of course, I'm nervous. It's my first conference talk. On top of that, I had an early morning coffee, so it's like more. I hope the coffee break worked out well for you. So I'm Dipro. I'm from Calcutta. I moved to Amsterdam 2.5 years ago. I work with DAZN. And I'm not sure how many of you know about DAZN. We are a live streaming website for sports. And we started having a dev center in Amsterdam from September. And I was very lucky to join them in November last year. Some of my colleagues are here. Thank you for coming as well. And because I work at a live streaming company, not that I'm involved with it, but I have a passion for understanding streams better. And I came from a computer science background, which means that I had to revise a lot of concepts before I went head-on with handling big data. So I worked with the payments and subscriptions team with some of my colleagues here, and we handle a lot of high traffic every second. And we have to be very highly resilient, fault tolerant, and we just cannot fail because it's live sports. Yesterday it was Netherlands versus England, and we streamed it live. And I watched that match. I don't know how many of you supported Netherlands, but I'm very happy they won 3-1. And I mean, if you're watching that match and you want to sign up, you want to give them a seamless experience, which means that I had to improve my Node skills a bit. I've been working with Node for 3 years or something, 3 or 4 years, and I've always been a consumer. You know, like I've been using so many concepts here and there. I've been using so many APIs here and there, but I didn't really have a chance to get the time and look under the hood and see how it's all happening. But then in the last year or a bit more than that, I've actually done some looking around, and I felt that I could actually share a bit with you, which is why I'm talking. And as you can see, I'm horrible with design, which is why I don't have a PBD. I just have a GitHub repository. And I published this on my GitHub link, and it's also shared on my Twitter. So if you follow me on Twitter, you can actually see my GitHub link, and you can go through this content, the code that I wrote, and you can hack around. I love Node.js and AWS. I work at DAZN with the stack. I mean, mostly serverless, a lot of that we do. And we use a lot of Terraform to jig all the infrastructure up. And we use Drone for our CI pipeline, and we use Node.js for application logic. And I absolutely love those two things. And I'm very passionate about discovering new stuff, learning new stuff, because I work with a lot of smart people. So like every day we are exchanging some stuff. And off late, I like sharing and repeating the whole process. I was not very comfortable with that, but now I'm slowly getting a bit better on that. Today's topic for me is to understand streams, signals, and events a bit better. So I'm sure you guys have worked with servers, whether you've used a framework like Express or Koa, or you've used a native HTTP server. I'm sure that you've handled requests to that. And maybe you've actually attached listeners to certain events, certain signals. Or I actually gave away a couple of free tickets because I did a contest, and I said, if you could answer this question, you could get some. I think one person is here answering that. And the question was, what happens when you press Control-C on your keyboard? And the answer is, you actually do a keyboard interrupt, and that sends SIGINT. And how does Node.js incorporate all that? And to be able to show that, I wanted to take a look with all of you together at the source code of Node. Some of our core contributors are here today. I'm sure they can teach us more. But as a consumer, I wanted to go and take a look at how it is all implemented under the hood, because sometimes it's a bit hard for me to understand the documentation unless I really go and take a look at how it is implemented. I will show how you can work hands-on with file streaming. So most of the talk today is around the Streams API. I'm not going to talk about how to implement streams, but I'm going to talk about how to consume streams, because most of my work is around that. And so it's like loading a large volume of data over a file, over HTTP, and I have to stream that file, and I can't load it all at once, because if I do that, then there's a huge memory overhead. And that means that my performance is slow, and I can't have that. And event-driven architecture is that an event is emitted, and you react to it. And it happens so fast at the scale that we work that we cannot have that overhead. So which means that we are going to look at how to do that. We are going to look at a few very basic things of Node.js, but understand what it actually does. Look under the hood. So like, how many of you have done console log in Node.js? All of you, right? And how many of you have heard of process.nextstick? Cool. So yeah, these two are super basic things. And I'm sure all of you have used streams. But how many of you are from a computer science engineering background? That's quite a lot. Yeah, so maybe some of the things that I start with are things that you absolutely know by heart. But to include everyone in the conversation, I would like to do a recap over the basics, so that we just get the basics right before we move on. And I'm also going to talk about the pipeline method, backpressuring, and signals, but we'll come on that later. I had no idea how to do CSS, so I don't know how to resize it, which is why I love JavaScript, but I quit front end like after a year of doing it, because somebody told me anything that can be written in JavaScript will be written in JavaScript. I took it to heart. I'm like, yes, you're right. I'm going to do just backend because I cannot master CSS. So what is a stream? I mean, if you look at it, it's probably one of the most or the best used metaphors. And I mean, I can't think of a better name for a concept that it represents, right? Like if you think of a stream, it's just a flow of anything over a period of time. And so is a stream in computer science. It's a sequence of data over time. And there are supporting data structures, like an array or a queue, that could come very close, right? An array also is a sequence of data. An array also is a sequence of bytes. A stream is also a sequence of bytes. So you can think of stream as that. It's just that it holds data over a period of time, which is useful for us because we work with event-driven architecture, distributed systems. But there are several things happening over a certain period of time, and we need to react to it. And that's what it looks like when we work with big data. It's a stream of events. And then let's come to what a pipeline is, right? So if we are talking about stream, and we are talking about data flow, then we are talking about flow of data from a source to a destination, right? It never happens that you just use a stream without a source and a destination. So the part or the medium that connects the source and the destination is called the pipe. And the flow of the data from one place to another is the interesting bit here. And that's where all the concepts of backpressure, drain, flush, all these concepts come. Because what is interesting is, and I'm going to take a real-life example. Like, you must have heard the word buffering. Like, we all consume video on demand, on YouTube, on Netflix, everywhere. And if our internet connection is not great, we see that it's buffering. What does it mean? If our internet connection is not good, it's buffering. If it's great, it's not. It's streaming live. So the reason is because the source is producing that video at a very high speed, but we are not being able to consume it. But what happens to this data? If we don't store it somewhere, it gets lost. So we don't see it. So it has to be stored in a temporary space in memory, which is buffer. And what happens if the source keeps producing a lot of data, but somewhere in the pipe, it gets stuck because the destination can't handle it, right? So we need to wait till the data has been flushed, till the data has been drained. And that's why this concept of backpressure comes. So it's the lack of flow, lack of pressure in the opposite direction, you know? That's why it's backpressure. So a pipeline, if you look at the Wikipedia or several sources of definitions, you know, I wanted to write it down because words do mean a lot. Our thoughts are so many in our head, and if we want to give life to our thoughts, if we want to give birth to our thoughts, we need to use words. And that is probably the most concise way I could have showed it to you. So it's a unidirectional channel of communication between processes in an operating system via buffering. So what is a process? What is an operating system? It's a medium for us to be able to communicate with the hardware. And in an operating system, what is a process, right? So let's say that we write a piece of software. We write a page of code, and it looks like this. And this program will get executed when we run node index. And when it does get executed, there is a dynamic instance, right, of this program. And that's the process, because that's running. That's the one that is executing the instructions in the program. That is being interpreted. It's being, however it is being compiled and interpreted, is being executed. And all these instructions get, they are routines. They are instructions in that program. And then a part of that process, a segment of that process is a thread. Now, we all know JavaScript is single-threaded. And off late, we have seen that there are multi-threads being introduced, which I honestly don't know much because it's quite recent. I haven't worked with it yet. So I'm going to assume for this talk that it's single-threaded. So that means that the entire program is one segment, and it gets executed top-down. But not really, because we do see lots of event listeners attached, which means that it might listen to a piece of code, and the moment that's emitted, it will execute that. And I'll get to that later. Let's go back to my amazing design markdown. So events. What is an event, right? This is an event. This is an event, right? We do some action, and then people react. So that's an event listener, like you're listening to me. This is an event. It's the same in Node.js. Everything in Node is probably an event. Like streams is an extension of event emitter. And I think almost everything is an implementation of streams. So in turn, everything is emitting events and listening to events. And I will show the source code later. But yeah, to just go deeper on the concept of event-driven architecture, it means that we have distributed system. And it's a collection of events where a person or a class or an object emits something, and we have subscribed to that. We have chosen some of the events to subscribe to, not all of them. And then we have attached our listeners. And whenever that event gets emitted, we act to that, based on which serverless has come up, right? We attach lambdas to something, to an event source. And every time that event source is triggered, the lambda gets triggered, and we do something. And it's done, and the lambda closes down. So it's on demand. I'm going to deep dive a bit more into process. So what does process have to do with us, right? A process has access to the file system resources, to memory. And at runtime, it has a stack, which is where all the local vars and the functions are getting executed in a stack top-down approach. There is a heap where all the memory allocation happens. There is data where the address to the next program, to the next instruction in the program is stored. And then there is text, which I don't remember what it is. And that is the state of a process. So like how many states a process can be in, right? A process is started when you execute it. Then it becomes ready to execute. Then it's running for some time, unless you ask it to wait. And then eventually it's done. It probably resumes because you have asked it to resume after waiting. And then it finishes its instructions, and then it's terminated. But what I haven't shown there, a process is an isolation. Like it doesn't share its memory with someone else. So if you have two processes, how do you communicate between the two processes? That's when signals come into play. And there are other ways of communicating between processes. There is pipes, where there is a pipe in the kernel that connects one process to another, and then you pump data into one another. And then there is signals, which is an asynchronous notification sent to a process or to a specific thread, blah, 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 which basically means it's an extension of an event. So one process says, hey, I have done something. Do you want to do something about it? Or it says hello, and then the process B says hi, talking to each other, inter-process communication. And that's what we do as well. So every time you create a server, you want to listen to events like SIGINT, unhandled exception, uncaught exception, and you want to do something on it. You usually log something or you want something, and then you do process.exit, which is basically killing the process. If you look at the activity monitor, well, right now there is nothing because I'm searching for Node and I don't have a Node process running. However, let me resize this. That was too fast. I have to do something to make it, but I can probably see something else. So let's say that I select that process. I go to view, and I want to show signal to process. And I have hang up, interrupt, stop, continue, quit, abort, kill, alarm, blah, blah, blah. And there are so many alarms that, signals that we have. And now I'm going to take the bold step to the Node source code. So I haven't shown how you can do that, but of course, if you go to the website of Node and you take the link and you do a git clone, then you get the website, and then you can take a look at it. So the Node source code has two major folders that you need to look at. One is the lib folder, where all the JavaScript is there. And one is the source, where all the C land is there, C and C++. And I'm going to look at a couple of C++ files now. Because if you look at the JavaScript file for process, there's literally nothing. It's just, yeah, because process is a global, but you can also require it as a module. So they just want to re-export it so that you can do const process equals require process. But how it is defined as a global is here. If I do, this is too many. Yeah, so this is where all the globals are declared. And process, as you can see, is a interface, is an instance of process, Nodejs.process, which is an interface that extends event emitter. So even process is based on event emitters because it has to listen to several signals, it has to subscribe to several signals, it has to remove those listeners, and it has to do something. So it is, and as I said, so I read it somewhere that streams are the most powerful concept in Node.js, but it's also the most misunderstood. And that is true because if you see here, std out, std air, std in, they're all streams. And what are they? Hold that thought, I'm going to come back to that later. Because every time we are logging something to a terminal, it is through a stream. And yeah, of course, we have all these variables. I think some of you may have tried to listen to the PID, which is the process ID. Some metadata if you want to profile your memory and you want to listen in which process is going on. And you want to look at your CPU usage, your memory usage, of course, the famous nextTick method, HR time. And yeah, here it adds all the listeners. Before exit, disconnect, exit. These are all the events that we usually subscribe to. And here are the signals that I wanted to show. And if I go to the signals, you see here we have all the signals defined. This is the list of all the Linux POSIX signals that we usually listen to. And now, let's go here. This is the first C land that we are going to see. So again, coming back to the answer that my question asked on Twitter, sig term, sig kill, sigint. So it's a switch case. Either of these three events are fired, you want to kill. Unconditionally terminate the process. On Windows, kill processes normally return 1, so that's the status code of the process. And if it's already terminated, then it returns an error that it's access denied. There is a catch here. If you listen to sig kill, your code won't run. Those are the files that got created when I ran node index. Where is index? Yeah. So I had to comment this out, process.on sig kill, and I'll show you why. If I uncomment it, uncomment, yeah. If I do this, there is a error. It says UV signal start E inval, and we're going to see what that is. So it says UV process kill. If you give any invalid value, then it's going to throw this error. And that's because sig kill cannot be actively listened to in our node process. It's just not allowed. So you can listen on sigint and any of the other ones, but not this one. And it's it's a very powerful tool because the other day, a couple of weeks ago, me and my colleague, we were troubleshooting our servers. And we didn't know why the server was consuming a lot of CPU memory. And it was terminating, but it was not really terminating. Because when I pulled up my application monitor, I saw that there were one node process, but it never got terminated. And why was that? Because we did not attach the listener properly to the sigint. We had listeners, but it was not doing its job. And that's why it's important that we profile an activity monitor and we do the signal listening well. I'm going to go back to my amazing diagrams. Do I have something left from this? Are you guys still with me with the basics? Is it still fine? Yeah? Cool. OK, so I'm going to, according to my plan, I was supposed to go hands-on work with file streaming. So yeah. So I have a file handler module, which does a few things. It writes rows to file. It reads rows from file. It returns a readable stream, and it returns a writable stream. And how I use it is, it's a really simple thing to do. So I have a main function that first shows you what the process ID is, what the platform is, what the parent process is, which is spawning this child process, and what the release version of Node is in this runtime of Node. And I want to have a benchmark, so I create a start timestamp, and then I create a finish timestamp inside the code. And what I'm doing is I first call the write rows to file, and then the read rows to file, which are not piped together. And then the third line number 13, where I'm calling write rows to file again, that returns a write stream. And then on finish, when it is finished writing to sample 2, I'm calling the get readable and get writable to get 2 streams and then pipe them to show how you can pipe 2 streams and write to a third file. And then, of course, I have my event listeners for this. This is how you can use the syntax for listening. So what's really different in these ways of writing and reading from files, right? Well, if you see the first one, this is the source of truth. This is the first time I'm writing anything. So I pass 2 values, value 1 and value 2. And I call main with streams and signals, and that's it. So sample 1 is called with values. It's going to have streams with a new line. So it's just going to do, how many zeros? 5. So 100,000 streams in that. And then sample 2 is going to have 200,000 value 2, which is signals. And that's all. So that's a lot of data, and I want to do it fast. So if I go back to the file handler now and just focus on how I'm doing this, So I try to get a stream, a write stream, by calling the fs.createWriteStream, which returns an instance of the writable class, implementing a few methods on top of that. And so I have that method called cork, and I want to talk about that. Why? Because if you don't use that cork explicitly, what happens is the data is not written to buffer. It's just written directly. And I want it to write to buffer so that it's not lost, which is why I cork it. And then I keep writing. And you see I'm returning a Boolean from write_stream.write, which is what is very key, because that's how backpressuring is implemented in streams. And I want to dive deep into it, but let's just for now assume that write_stream.write returns a Boolean. If it's true, that means it's all good. It is draining data. So we can go ahead with it. If it's false, then that means that the data is jammed in the pipe. I don't know if that's a real word, but in Indian English it is. So it means that it's stuck. And that means that we can't go ahead with the writing. So we want to listen to something. We want to have a check that if it's not draining, then we want to listen to the drain event. But I write here once because I don't want to have too many listeners. Otherwise, I have to do a set max listener so that I don't get that warning. And so then I just log stream is draining again, and that's it. Then I do a process.nextTick. So what process.nextTick does is, and it's a bit tricky because the name is not very obvious. So if you have an operation going on, and I don't mean event tick, I mean in your current phase in the event loop, if there is a current operation going on, then it will first complete that operation, whatsoever that may be, whichever phase it might be in. And once that's done, the callback in the next tick queue will be executed. And that means if you overuse it, you abuse it, then you will starve the event loop. But it's very handy in places where synchronous or asynchronous code is not guaranteed. You don't know what's the nature of that function, and you just keep writing data. And then at some point, you're accessing a variable that is probably not there yet. The program hasn't reached there yet. And that's where process.nextTick is super useful. But it's not the same as setImmediate. SetImmediate makes you think that whatever callback is passed to setImmediate is going to happen right now, but that's not true. It's going to happen in the timer phase when the control pass is there. So that's in the next tick of the event queue. And process.nextTick is actually setImmediate. For some reason, the names are interchanged. And then at the end, I return writeStream.end. And I pass something over there. I pass a text, a string, and I pass a callback, which means that when I do that writeStream.end, it's going to write that one last file before it finishes. And then it's going to have a benchmark, and it's done. And it's going to do the same with the read rows. I have the same here. If you see here, I have a very strange syntax. It says for await const chunk of read stream. That's because it's an amazing feature in Node 10 that we should be using instead of listening to the event called data. And readable stream just returns a read stream with high watermark as 1024, which means that you read 1024 chunks at a time, and the same for encoding, and the same for a writable stream. And I go back to, OK, now I have to show the source code. So if I now look at stream writable, and we look at this part where it says we must ensure that the previous need drain will not be reset to false. So we need to look at this function write or buffer. This is the underlying method that is being called when you call write function. And then it gets the ret, which is the state.length less than state.high watermark. So the length of your state should be less than the chunk of data you can process. And if it's true, then that means that you don't need to drain. But if it's false, then you need to drain. And this is the logic here. And you return the ret here. But if you, and it's written in the documentation, if you actually play with that and you just return true all the time, you disable the by default backpressuring support from Node.js. For stream readable, what's important is the pipeline, because that's a very powerful concept. If you don't want to actually listen to the drain event and you want to have a seamless pipeline, then a much better way to do it is to compose, because the usage of streams is not just handling big data. It's also giving you the power to compose your data structures, just much like you do with arrays. And you take two streams and you pipe them. And here I'm doing nothing. I'm just reading from the stream from that file, and I'm writing to that without doing anything. You know why? Because pipe is doing that by default. If you see here, the pipe function, it has a listener on pipe, it has a listener on end. And of course, it has a listener on drain inbuilt. So we don't have to do any of the writable methods by ourselves, because the pipe function does that by itself. Which is, I think, most of what I had to share. But the last one bit. If you add console log in a large for loop, which is handling a file stream, you will notice that the processing takes a lot of time. And that's because console log itself is a stream. I don't know if you had known that, but let me show you how console is actually implemented. So this is the global, where console is exposed, which is why you don't have to require console. And this is where it's actually defined. And you see here, this is where the log method is defined, and it says this.kwrite to console. So it's using a function, kwrite to console. And then it is actually defining the kwrite to console method on the prototype of the console class, which is the parent, and it's being extended. And it's a stream, because it is extending std out of process, which means that if you're going to implement console.log in a big data for loop, it's going to just delay the process. And I'll end my talk with just one demo, because you saw that it was quite fast, right? I'm going to add something here. You see how much time it took? 2485, and the last time it took like 8 milliseconds or something. And this is why we don't write console logs in production, and we don't write console logs at all. We might write our own logger file. We might also reduce the number of logs. We might turn on a flag. But this is why it is prohibited in production. I think I have gone over time. I don't know if I have something remaining. This is just to show that it actually did what it was supposed to do. I think that's about it. Thank you. I hope this helps your understanding of Node.js. Thanks.